morning, mathematicians. We are on our Tuesday column of week 14. Number 1 says the combined volume of two identical cubes is 250 cubic centimeters. What is the measure of one cube's length? Well, first of all, one of the things we need to know is, of course, a cube has all three dimensions that are the same. So whatever the length of this dimension is going to be the same as this, is going to be the same as this, right? That is the nature of a cube. Now, both of these together are 250, so I know that this one is 125 cubic centimeters, and I know that this one is 125 cubic centimeters. Now, the question is asking us, what is the measure of one of these lengths? So really, I know that the length times the width times the height has to equal 125, and I know that it has to be the same number in each of these. So really, it is this variable plus it again has to equal 125. Now, a lot of us, because we have been practicing questions like this, we might have an idea of what can sit in here. Now, let's try out that idea that I hear over and over again from our students on this. Would 5 work? Well, 5 times 5 is 25, and 25 times 5, does that equal 125? If you have 5 quarters, how many pennies do you have? You have 125. So we do know that the answer to this question is that, yes, the height is going to be 5 centimeters. The width is going to be 5 centimeters. The length is going to be 5 centimeters. What is the measure of one cube's length? It is going to be 5 centimeters. So we can list it just like that. Now, if you are unsure, you could take this number and divide it by 3, because we know that all 3 dimensions are going to be the same. So especially in the future, if it were a number that you were not as familiar with, or even if you didn't see the 5 here, this is the strategy that you would want to utilize to figure out what one of those dimensions are, because, of course, it's the same for the length and the width and the height. Let's go to this. Ceiling Dion's bathroom dimensions are 11 feet. I'm going to write these down. By 10 feet by 10 feet. Her kitchen has the same height, but double the volume. Give another set of possible dimensions for the kitchen and calculate the kitchen's volume. Okay, now again, this is the bathroom. I'm going to put BR. So at the beginning of this question, we were told that the bathroom has these dimensions, right? Well, 11 times 10 would be 110, and times 10 again would make it 1,100, because we're going to have our 11 with 2 zeros. So this is the bathroom, just for reference. Now we're thinking about the kitchen. Now the kitchen has the same height, but the volume will be doubled. So our answer has to be double. So it's going to be a 2 and a 2 and a 0 and a 0. It's going to be 2,200. Okay. Now, this is a question where we can arrive at different dimensions, but this, our answer has to be the same, because it has to be double the volume, right? So, just for the sake of talking this through, I'm going to go ahead and let the 11 represent the height. Okay, if my 11 had represented the height, then it would be the same down here, because that is what we were told, right? That it has the same height. Again, you could keep one of these other dimensions, the height for you, but how I play with my other dimensions is going to have to be the same, no matter how we do this, okay? So I'm leaving my 11 the same. I'm saying that that 11 represented the height. So now, what am I going to do with this dimension and this dimension so that I'm arriving at double the height? Well, what do I have to do? I have to double one of these, and the other one is going to stay the same, right? So instead of a 10 here, I'm going to double this. I'm going to make it 20. And my other dimension is going to stay the same. That's how I'm going to end up at double the volume from what I had here in the bedroom. And indeed, if I have 11 times 20, I have a 2, and a 0, right? Because 11 times 2 is 22, and then there's 1 0. If we multiply that by 10, we can see we've arrived at our double the volume, which is what we were. So down below, we have to list the dimensions of the kitchen. So I'm going to say that I had 11 times 20 times 10, because it did say to give another set of possible dimensions, I went ahead and listed those down below. Now you could also write out 11 feet height, right? 20 feet width, 10 feet length. That would be another way you could report it. But this is one set of numbers that does achieve what we were asked to do. Now down here it says sketch out one of the possible kitchen designs. So my height has to be 11 because I was told that that needed to stay the same. So when I look at the prism that I'm drawing, I'm going to go ahead and start with the height because that's the one that stayed the same between the bedroom and the kitchen. The other, this one, I'm going to make my length doubled. This one stayed the same as well, right? So 11 feet was what stayed the same. I'm going to make my length 20. Does this line look just a little bit under half of that? Yeah, it does. We do want to make this look realistic. So now I am showing one face of my kitchen where it is 11 feet by 20 feet. I can go ahead and write that unit here. So I need to now show the width being 10. So I'm going to draw this going back. And now I have an idea of how that kitchen will look. I've drawn it as a prism, sketched it out. That is one possible kitchen design. All right, let's take a look at our next question. This question says, shade 1/3 of 1/3 of the below square. So I'm going to be showing 1/3 in my columns, and I'm going to be showing 1/3 in my rows. And I'm going to see where the overlap is, right? So here I'm going to go ahead and draw 3 rows. Not so much to scale, but that's okay. And I'm going to shade how many of them? I'm going to shade 1/3 of them so that my mind is already preparing to see where that overlap will be. Now I'm going to take a look at my columns and I'm going to shade how many of them? I'm going to shade one of them because now I see 1/3 in my columns and 1/3 in my rows. And where the overlap occurs, this is the moment where I see 1/3 of 1/3. Okay, a lot of times when we're showing this as an answer, we don't see the shading continuing in the rest of the column or the rest of the row, and that's okay because this is the important moment where we see that overlap occurring. Now let's go down below and we're going to do something similar, but we're going to add something to it. It says fill in the below diagram to show the following. 1/3 times 1/2 equals 1/6. So we are told the factors, which we were told the factors here. We're also told the answer. Now I just have to create a diagram to demonstrate or to show this, right? So I'm going to go ahead and I'm going to put my 1/2 this way. I'm going to put my 1/3 this way. Let's go ahead and in our columns, we're going to have 2 columns and we would have a shading in one of them. I'm not going to fill it in right now. You certainly could, but I'm going to do this just a little bit differently to match some of what I'm seeing students do on this week 14. Here, I'm going to make 3 rows and I'm going to imagine that there's shading in one of them. Now, where would the overlap be? The overlap would be right here, wouldn't it? And I also know this because this one is an equation. It did give me my answer. Do you see one rectangle out of the 6 rectangles shaded? Sure enough, we do. And that finishes out